बच्चे लोग, students, let me tell you something before I start my coaching for binomial theorem. Any lecture or any study lecture is like doing a meditation. In meditation, what you have to do? You have to just stop thinking, concentrate on only one object, and that is what? Learning. Remove all your prejudices about the subject, about yourself, that I am not good. Or if you think that I am not good in the subject, remove that, keep it aside. It's a chappal which you keep outside the temple. Then there is another feeling that I am not good at mathematics. Keep that feeling away. Just think you are the best and you are the best person to learn mathematics. And there is a best person to teach you mathematics. Keep these three beliefs and like a meditation, concentrate on every word that I am speaking, right? You will find wonders, The learning becomes infinitely easier if you keep these three beliefs away. Okay, number one. Now let us start with the topic of today, that is called binomial theorem. Now this word binomial is made of two words. It's a combination of bi and nomial. Bi means generally in Greek alphabet it means two, and nomial ka matlab hai terms. So that means two term ka theorem, right? Binomial theorem. So why it is called two terms? Because it deals with the expansion of this particular bracket, x plus a bracket raised to n, right? Now how many terms are there? There are two terms here. That is why it is called binomial theorem. If the number of terms increased, then it is called polynomial theorem or multinomial theorem. So instead of x plus a, suppose you have something like x plus a plus b plus c and so on. This kind of theorem will be called multinomial theorem. Multinomial theorem, right? And it is very, very strange and very, very magical that if you understand the basics of binomial theorem, you can understand basics of multinomial theorems also very easily, right? But that is not a part of our syllabus, so we will not deal with this topic as such today, okay? So basically what we are interested here, we are interested in trying to expand this bracket x plus a raised to n. Now, many times, I always feel that the student should know how and why exactly this binomial theorem is expanded, So for example, what is x plus a raised to n? If you write it in ordinary language, it means it is x plus a multiplied by x plus a multiplied by x plus a. This goes on till you reach nth term. Correct? For example, if x plus a square is there, there are only two terms. If x plus a cube is, there are three terms. If x plus a raised to 10, there are 10 terms, like that, right? So here, we are assuming that there are n terms. N is a general number. We can keep any number in place of n, any integer, okay? Now, I am asking you, I want to multiply these n brackets. How would you multiply? Now, we are taught multiplication right from our childhood. मल्टीप्लाई कैसे करना है हमको बचपन से सिखाया जाता है, लेकिन रियली स्पीकिंग वी डू नॉट नो व्हाट इज द मीनिंग ऑफ मल्टीप्लिकेशन. दैट विल बी सरप्राइज्ड. सर हमको मल्टीप्लिकेशन नहीं आता है. बिल्कुल नहीं आता है, क्योंकि आपको पता नहीं चलता है कि आप जब अगर मैंने तुमको बोला x प्लस ए रेस टू 3 करो तो तुम क्या करोगे मेरे को मालूम है. x प्लस ए रेस टू 3 आपको बोला तो आप क्या करेंगे, पहले दो बार मल्टीप्लाई करेंगे. x प्लस ए मल्टीप्लाइड बाय x प्लस ए दो बार करेंगे और फिर ये दो बार जो आंसर आएगा उसको x प्लस ए से मल्टीप्लाई करेंगे तो हमको 3 बार आएगा. लेकिन ये जो मेथड है ये रिकर्सिव मेथड है. मतलब अगर आप 2 का एक्सपेंशन करोगे तो तीसरा आता है, तीसरे का एक्सपेंशन करोगे तो चौथा आता है. सो दिस 100 अगर टर्म 100 है तो 99 टाइम्स तुमको करना डिफिकल्ट है. दैट इज नॉट अ प्रैक्टिकल मेथड ऑफ एक्सपांडिंग. सो यू शुड अंडरस्टैंड व्हाट इज द मीनिंग ऑफ x प्लस ए क्यूब. x प्लस ए क्यूब का मतलब है x प्लस ए इंटू एक्स प्लस ए इंटू एक्स प्लस ए 3 बार मेरे को मल्टीप्लाई करना है. मल्टीप्लाई करने का मतलब क्या? मल्टीप्लाई करने का मतलब यह है कि हमेशा आई हैव टू चूज 3 टर्म्स. रिमेंबर हाउ मेनी टर्म्स? आई हैव टू चूज 3 टर्म्स बिकॉज इट्स 3 टाइम्स एक्सपेंड करना है. और मेरे पास 3 बॉक्सेस है. एक बॉक्स है जिसमें एक्स प्लस ए करके 2 ऑब्जेक्ट्स है, दूसरी बॉक्स है एक्स प्लस ए वाली, तीसरी बॉक्स है एक्स प्लस ए वाली. So this is a box number 1, first box. This is the second box and this is the third box. Correct? Now, every time I have to select one object from each box. Correct? That is compulsory. And how many objects I will select at a time? 3. So, I will exercise my first choice. मेरा पहला बॉक्स लिया, उसमें से मैंने x को उठाया. So, पहला बॉक्स लिया, उसमें से मैंने x को उठाया. दूसरा बॉक्स लिया, उसमें भी x को उठाया. तीसरा बॉक्स लिया, उसमें भी x को उठाया. फाइन. सो x का चॉइस खत्म हो गया. राइट? अभी सब में से x निकालना पॉसिबल नहीं है, वो हो गया. फिर अभी मैं क्या करूंगा, 2 बॉक्सेस में x निकालूंगा. तो ये x और ये x, तो क्या होगा, x स्क्वायर. और रिमेनिंग बॉक्स में मैं a निकालूंगा. करेक्ट? सो what am I going to do is this. From these 2 boxes, I will choose x. First box में x, second box में x, third box में a. बाद में first box में x, second box में a, third box में x. बाद में first box में a, second box में x, third box में x. करेक्ट? इस तरह से मैं एक दूसरा चॉइस हो गया. इसमें मैंने x 2 बार लिया और a 1 ही बार लिया. करेक्ट? तो अभी 2 बार x 3 बार लिया था, अभी 2 बार लिया, अभी मेरे को सिर्फ x 1 ही बार लेना है. सो पहले बॉक्स में मैंने x लिया. राइट? दूसरे 2 बॉक्सेस में मैंने a लिया. अभी क्या हो गया कि दूसरे बॉक्स में x लिया, इसमें a लिया, इसमें a लिया. फिर बाद में दूसरे a इधर से लिया, पहले बॉक्स में a लिया, यहाँ पे x लिया, यहाँ पे a लिया. करेक्ट? बाद में हमने a इधर लिया और x इधर लिया. करेक्ट? और लास्ट में अभी मेरे पास x का कोई चॉइस ही नहीं है, क्योंकि x 3 बार हो गया, 2 बार हो गया, 1 बार हो गया. अभी मेरे को x लेने की जरूरत ही नहीं है. 3 ही बार मैंने को क्या लेना है, a. अभी नंबर ऑफ टर्म्स देखो कितना हो गया, 1 2 3 4 5 6 7 and 8. As it is 2 into 2 into 2, 8 terms. All terms are over. Correct? So therefore, what is this actually? This looks like x cube. Correct? This is x cube plus x square a plus x square a plus x square a plus x a square plus x a square plus a square x plus x, मतलब x square a, हाँ 3 बार. So x a square, right? And last I have is a cube. Correct? Now if you actually look at it, it becomes like this: x cube, x square, this term is repeated 3 times. So 3 times x square a. Then ये जो तीसरा टर्म है ये भी 3 बार रिपीट हुआ है, तो x a square 3 times x plus a square, और ये क्या है, a cube. Finish. This is exactly the expansion of a trinomial theorem. That means trinomial means what? Not trinomial. I mean x plus a is raised to 3. So this is x cube 3x square a. If you recall the formula that you have learned in 10th standard, this is the formula that you have learned, right? This formula generally is written as x cube plus a cube plus 3xa multiplied by x plus a. But that's the same thing. If you expand this bracket, then you will get the same term. So that means if I want to expand binomial theorem, that means I got how many boxes? N boxes. I got n boxes. And I am creating a word. That word is made up of n objects selected from every object. For example, I may choose x. How many times? N times. That will lead to x raised to n, right? Now, if I choose x n minus 1 times, so x, I will choose n minus 1 times, last number will be a. So, and this a can be chosen from the last bracket, second last bracket, third last bracket, fourth last bracket. That means I have got exactly n choices. So, therefore, it will be n times x raised to n minus 1 multiplied by a. I don't know whether you are understanding this, but this is a very simple concept. And if you don't understand this concept also, I am going to tell you that there is a very simple method of expanding a binomial theorem. So let us get into that. If you look at my permutation combination lectures, in the last lecture I have already given you the wonders of Pascal's triangle. Now this Pascal triangle is of great help as far as binomial theorem is concerned. So what is it? The Pascal triangle says that we are using a Pascal's identity. That Pascal's identity is this NC0. First of all, let us find out NCR plus NCR minus 1 is equal to N plus 1 CR. Correct? This is a Pascal's identity. This Pascal's identity gives rise to a very, very interesting triangle, and that triangle is called Pascal's triangle, right? It's a repeated application of this particular identity which gives rise to Pascal triangle. Now this Pascal triangle, how does it help us? Let us see. So first of all, let us have 1C0, and here suppose I have 1C1, right? Then according to Pascal's identity, this can be if I add these two, this should become 2C1, correct? NCR minus 1, NCR is equal to N plus 1 CR, correct? That is the identity. Now here what I do is, I just add here 2C0 and here I'll write 2C1, 2C2, sorry. So 2C2, correct? Now I add these two, right? 2C0 and 2C1, that will give me 3C1. And 2C1 and 2C2 should give me 3C2, correct? And here I'll additionally write 3C0 and here I'll write 3C3, okay? So every time I'm adding this first and last number, okay? That is 1, you all know. Now if I add these two, right, then I'll get here 4C1. If I add these two, then I'll get here 4C2. If I add these two, then I'll get 4C3, correct? As usual, I will keep writing here 4C0 and 4C4, right? So you can see this magical composition, magical poem of so-called Pascal's triangle. It keeps on and on and on. Why am I doing it? Because you will realize one thing, that 1C0 is 1 and 1C1 is also 1. If I add these two, I'll get 2. I'll have 2C0 is 1 and 2C2 is also 1. Then I'll start with 1 again. Again I add this. This is 3. This added 3. This is 1. This is 1. This 2 if I add, I'll get 4. If this 6, this is 4 and this is 1. This is 1. This is 5. This is 10. This is 10. This is 5. This is 10. This is the Pascal's triangle. Why is it important? If you have a casual look at it, you will realize the first term is 11. Second term is 121, which is second power of 11, 11 square. So this is 11. This is 11. What is this? This is 11 square. What is this? This is 11 cube. What is this? This is 11 raised to 4. What is this? This is 11 raised to 5. Not only that, these are actually what I said, these are called what? Binomial coefficients. For example, if I write x plus a, yeah, and I want to raise it to only the first power, so then it becomes just x plus a. So what is the number which multiplies x? It is not visible, that means it is 1. a का multiple क्या है? 1. So इसके जो coefficients है वो 1 1 है. ये coefficient है, ये coefficient है. ये दोनों 1 1 है. अगर मैंने x plus a square लिया, तो you all know the expansion is x square plus 2ax plus a square. Okay, so that means this term, the coefficients here is what? 1, right? Here it is 2 and here it is 1. Exactly represented here. Now, if I take x plus a cube, then it will be x cube plus 3x square a plus 3xa square plus a cube. Now, if you look at the coefficients here, it is 1 here, 3 here, 3 here and 1 here. 1, 3, 3, 1. So, we are convinced that these numbers are definitely representing the numbers which are multiplying the terms, correct? They are called coefficients and each coefficient is called binomial coefficient, right? So, these are the binomial coefficients. So, for example, if I apply this method, okay, so suppose I ask you, now how useful is this technique? Simple. Suppose I want to find out x plus a raised to 6. Okay, how many terms x plus a raised to 6 will contain? remember it will contain exactly 7 terms. Okay, like for example, x plus a raised to 1 contains 2 terms, x plus a raised to 2 contains 3 terms. So the power plus 1 is the number of terms. So here I will have terms. So first of all, I will just write the terms without the coefficients. I'll just write the terms. Suppose I write the terms here. Okay, what is the first term? First term will have x raised to 6. I'm sorry, I think I will need a more space. I'll start from here. So it is x raised to 6. Then I'll need what? X raised to 5. Then I'll need what? X raised to 4. The powers of x will gradually go on decreasing by 1. So here the next term will be x cube. And next term will be what? X square. Next term will be what? X. Last term will not contain a x at all, right? So now x raised to a, now here x raised to 5, but there will be an additional term here a. Now the powers of a will keep on increasing. Here power of a was 0, here it is 1. So it is a raised to 0 here, right? Here a raised to 1, here a raised to 2, here a raised to 3, here a raised to 4, and here a raised to 5, and last will be a raised to 6. Correct? So this is how the terms are going to be this. But the multiples, that means the numbers or the coefficients, binomial coefficients, can be selected by using this triangle. Now here I want 7 terms. I got 1, 2, 3, 4, 5 terms here. Here I got 1, 2, 3, 4, 5, and here is one more, 6 terms. Now I want 7 terms. That means I'll just go ahead by only one step ahead, right? So that means it is 1, this is 6, this is 15, this is 20, this is 15, this is 6, this is 1, correct? So 1, 2, 3, 4, 5, 6, 7. I got 7 terms, and these 7 numbers will multiply these terms. So 1 multiplied by this. So this is 1 here. Plus, now x raised to 5, right? So the next term is 6. So the coefficient here is 6. Next term is, coefficient is 15. So here it is 15. Next term is, coefficient is 20. So here is 20. Next coefficient is again 15. Next coefficient is again 6, right? And the last coefficient is 1, correct? Also remember one thing, the first last is same, second last is same, third last is same. Only this term is different because the number of terms are odd. If the number of terms are even, then you will always get pairs, right? So therefore, that is why it is happening, because NCR is same as NCN minus R. So therefore, it is natural that this term and this term should be same, okay? So therefore, this is how I can find out the expansion of the x plus a raised to what? 6, okay? But now, this method is also recursive. So if I want to find out 100th power, then I'll have to keep on writing this triangle for 99 times. That is not practical. So let us have a practical method of expanding a binomial theorem. So let us have a formal statement of binomial theorem. What is it? Formal statement of binomial theorem is very simple, and it will be very clear to you from the way I have explained it to you. Okay? Now, what is formal statement? Formal statement is like this: x plus a bracket raised to n, that is called theorem. So that theorem I am writing here. X plus a raised to n means what? I have to choose x how many times? N times, right? And therefore, and I do not choose a at all. So that means I have to choose x from all the terms. That can be done in NCN ways. NCN is always 1. Therefore, this is NCN, which is same as NC0. That means I don't want to choose a at all, right? And here I'll write what? X raised to n. Okay. Next term, I will choose a only from one term, right? So how many brackets I have? N brackets. So out of n, I will choose one bracket to select a, and from the remaining, I'll choose x. Therefore, it is x raised to n minus 1 into a. Now, what is the next choice I have? Next choice I will choose a from 2 brackets. There are 2 brackets, there are n brackets, out of which I'm going to choose 2. So that can be done in how many ways? NC 2 ways. And I will choose a twice. So therefore, from the remaining, obviously, I'm going to choose x. So x ka power ho jayega n minus 2. Correct? Now, if you start building this up, so next is very simple. Now, you should remember the pattern here. This is 0, this is n minus 0. This is 1, n minus 1 is the power and a comes here. N minus 2. So, you can clearly see a pattern. This is n. This is everywhere it is n. This is 1, 2, 3, like that it goes on. And n minus 1 is the power of this and this is the power of a. Correct? So, in general, if I want to write, all my observation lead to what? NCR. Suppose I write rth term. So, it is NCR. What will be the power of x? Power of x will be n minus r. You can clearly see. And then power of a will be what? R. Because that is what is happening everywhere, right? In the last term, this will go on. This will go on. This will go on. Last term will be what? All the terms you are going to select only a and nothing else and no x at all. So, NCN and there is no x, that means x raised to 0, but a comes how many times? A raised to. Followed or not? So, this is the statement. This statement is called binomial theorem. Right? So, now this is binomial theorem, right? Now, this binomial theorem becomes very interesting if I replace this a by 1. Now, see what happens. So, another way of looking at it is like this, this is NC0 is actually what? 1. So, 1x raised to n. What is NC1? It is n upon 1 factorial into what? X raised to n minus 1 into a. What is NC2? It is n into n minus 1 upon 2 factorial into x raised to n minus 2 a square. What is NCR? NCR is n into n minus 1. It goes on till you reach what? N minus r plus 1 because there are r terms here divided by what? R factorial into what? N raised to n minus r into a raised to r, right? And the last term is going to be simply 1 a raised to n, correct? So, these are the two versions of writing this. But if you know the formula for NCR, you need not remember it because it comes automatically, right? So, this is the first term. Can we see this? This is the first term. What is this? Second term. What is this? Third term, and so on. But when the term is 3, this number is 2, and that 2 is subtracted from n from this number, and that becomes the power of 2, the a also. Okay. So, NC2, correct? So, therefore, this is what is happening. Okay. So, in general, what is the rth term? What? Let us see. What is the first term? T1 is what? NC0, x raised to n minus 0 and a raised to 0. So, this 0 is repeated here, here and here. And here it is n, correct? Now, what is T2? If I want to write T2, I will write NC1 because this is 1 less than that. And then, very simple, this minus this, right? And a raised to what? 1. If I want to write T3, I will write NC2. And here it is x raised to n minus 2 into a square. Fine, fantastic. So, if I want to write T10, I can immediately do it. That is NC9, NC9. X raised to what? N minus 9 and a raised to what? 9. Now, I think you got a hang of how to write an rth term. So, therefore, rth term, or rather I will take r plus 1th term, correct? R plus 1th term, r plus 1th term, r plus 1th term of binomial expansion is given by, okay, let us remove this now because we don't need this. We already studied it, okay, is nothing but, okay, is nothing but, since it is r plus 1 term, n, c, it is 1 less than r plus 1, therefore it is NCR, okay. Thereafter, it's very easy. We have found out that power of x is this minus this, so n minus r. Then we also found out that power of a is nothing but this, so NCR. So r plus 1, let us call it TR plus 1. This formula plays a crucial role in deciding the term, right? That is called binomial theorem, okay? And we'll use these formulas and so on. So what are some simple consequences of this? For example, what is the sum of binomial coefficients? In last chapter or last lecture, I have already shown you a different method of proof, right? I have already proved that NC0, NC1, NC2 and so on, right? NCN. What is it? Sum of all binomial coefficients. Binomial coefficients. Remember what it is? I proved it last time that this turns out to be what? 2 raised to n. Why? For the simple reason that whenever I select any subset, then either I select certain element or not select. So on every set, I am putting a tick or cross. Selected, tick. Not selected, cross. So how many ticks and cross are there? That means every object can be selected in two ways, either selected or rejected, right? So there are for every object there are two choices. So 2 multiplied by 2 multiplied by 2 multiplied by 2 n number of times. So therefore it becomes 2 raised to n. That is what I had explained. Now if you find that is difficult, then I will have a very simple proof of this. Let us see. 2 can be written as 1 plus 1 raised to n, correct? So 2 can be written as 1 plus 1 raised to n. Now in this expansion, x will be what? 1. And what is a? A will be also 1. So what is tr plus 1th term here? It will be n c r then multiplied by 1 raised to n minus r then 1 into r. So what is that? 1 का any power ncr ही होता है और ये 1 का power भी 1 ही होता है. That means this is equal to what? ncr only. So r plus 1th term here is nothing but ncr. So every term will become what? This is the first term, second term, third term, fourth term. Now what is that? That is 1 plus 1 raised to n. That is 2 raised to n. So I got another proof of the same factor, right? So there are multiple proofs of binomial theorem, okay? So the sum can be expanded like this, okay? Or if you want a detailed analysis of this, I'll show you like this. See, 1 plus 1 raised to n, right? So first term is 1 raised to n. Second term is nc1, 1 raised to n minus 1, 1. Then next term is nc2, 1 raised to n minus 2, 1 square. It goes on. Last term, ncn, 1 raised to n. But these two brackets add up to only 1, right? So therefore, it gives you clearly nc0 plus nc1, etc., ncn, right? And this happens to be equal to 2 raised to n. That's a very interesting consequence of binomial theorem. Now, let us slightly deviate from the this binomial theorem. Suppose instead of x plus a, I am finding x minus a. What is the change? I have expansion of what? X plus a raised to n. But I want to find out x minus a, right? So x minus a. So you will be wondering what the change should I make here? Actually, there is no change because these two terms are not different at all. All I have to do is write this in this particular manner. So how can I write it in this particular manner? It is x plus, only thing is second term is not a, it is minus a raised to n. That's all, correct? So therefore, again this expansion will give you what? Let us see. First term is what? nc0, x raised to n. Second term is what? nc1, x raised to n minus 1 into what? Minus a, right? Then next term is what? nc2, x raised to n minus 2. That means minus a square. I'll add one more term. So nc3, x raised to n minus 3 multiplied by minus a cube. And so on and so forth. Till you reach what? Till you reach ncn minus a raised to what? N. Correct? But minus has got alternating powers. Minus raised to 1 is minus. But minus 1 raised to 2 is plus. Minus raised to 3, minus. So the sign of expressions keep on changing. So it becomes like this. nc0, x raised to n. Now it comes minus. nc1, x raised to n minus 1 into a. Then plus nc2, x raised to n minus 2, a square. Then minus nc3, x raised to n minus 3 into a cube, and this is gone. Last term, since I do not know the value of n, I do not know whether it is plus or minus. So I'll write it as minus 1 raised to n into ncn, but ncn also is 1. Therefore, ncn into a raised to n, right? So the only difference between x plus a and x minus a, here the signs are alternating, right? And here the signs are same. What is the consequence of this? Let us see now. Very interesting. What is 1? What is 1 minus 1? What is 1 minus 1 raised to n then? Interesting. So what is 1 minus 1? It will be alternating, no? So it will be nc0 minus nc1 plus nc2 minus nc3 plus nc4 minus and so on. Last will be minus 1 raised to n ncn. That is very interesting because 1 minus 1 is what? 1 minus 1 is 0. So this term turns out to be 0. So 0 is equal to, let us take out all positive terms together. So nc0, nc2 positive term, nc4 positive term, all even numbers 0, 2, 4, etc. they will be positive, minus if you take all negative terms and take out minus sign common, then it will become nc1 plus nc3 plus nc5 and so on, right? And this total is always equal to what? 0. So if I take these odd terms on this side, okay, what do I get? I get a very, very, very interesting result here, that nc1, nc3, nc5, all the binomial coefficients where r is an odd number is equal to nc0 plus nc2 plus nc4 and so on. So here all binomial coefficients are there where r is even number. So here r is even. R is even, and here R is odd. R is odd. But the total remains what? Same. But we know that the total of all these coefficients is 2 raised to n. Correct? So if the sum of all these numbers is denoted by O because they are odd, and sum of these numbers is denoted by even and denoted by E, then 2 raised to n is O plus E. But O is equal to E. Right? We already proved that O is equal to E. Therefore, this becomes 2E. So 2 raised to n becomes 2E. That means E is equal to 2 raised to n upon 2, which is 2 raised to n minus 1. It is the same as O. Therefore, O is what? 2 raised to n minus 1, which means sum of all even binomial coefficients is equal to sum of odd binomial coefficients, and each sum is nothing but 2 raised to n minus 1. So now I want you to understand, students, what we started. We started with a binomial theorem. I told you binomial means bi and nomial. Bi means 2, nomial means term. So it's the expansion of 2 terms. For example, x plus a raised to 1, x plus a raised to 2, x plus a raised to 3. If I want to find out x plus a raised to 100 or x plus a raised to any power n, then what is useful to you is binomial theorem. Binomial theorem means what? It says that x plus a raised to n can be written as nc0, x raised to n, nc1, x raised to n minus 1 into a. Power of x goes on decreasing from n to 0. Power of a goes on increasing from 0 to n. Right? That is how the binomial theorem is constructed. And we already proved there are 2 identities. One is sum of all binomial coefficients is 2 raised to n. Sum of odd binomial coefficients is equal to sum of even binomial coefficients, and each total is 2 raised to n minus 1. Correct? With this, we'll stop here today and we'll solve some problems in the next lecture. Okay?